Hey everybody, today we're going to try to finish up the 2018 MCAS, and this is session 2, so we're going to be using a calculator. We're also going to be using the reference guide, which is with a formula sheet, which is attached to the back. And let's get started. Okay, so, oh, by the way, there's a PDF of this in the video description, so hopefully you've already tried this, and you're watching these videos for a little bit of explanation. All right, this is an open response question, or they call them constructed response questions now. Kite PQRS has diagonals that intersect at point T. The kite and some of its angle measures are shown in the diagram below. So we have a diagram here. The length of RS is 20. So we're told that this is 20 centimeters. All right. So if you're taking the MCAS soon, the Math MCAS here is coming up in about a week or so. You won't be able to write on a piece of paper because more than likely you're taking it, like most students, on a computer. But some of our students use dry erase markers, which I actually think is a very good strategy to draw on the screen. So anyway, it's something you can do. Or you can just redraw the shape on a piece of scrap paper. So we have RS here, it's 20. What is the length in centimeters of PS? Show or explain how you got your answer. Okay, so we know that these two sides are going to be congruent because it's a kite. This kite has two pairs of congruent sides. All right, so this would be 20. Actually, I'm going to use a different piece of paper for this one. So A would be, let me read this. Part A would be 20 centimeters. Definition of kite. What is the length to the nearest tenth of a centimeter of ST? So we're solving for this. Want to know what that is? Show or explain. All right, so this is a 90 degrees. 60, that means this has to be a 30. So this is a 30, 60, 90, which means it's a special right triangle. That's very important. So if we look at our 30, 60, 90 formula right here, we have the values. So this is the hypotenuse. So this is twice the length of the short side. This is the short side. So this is 20. That means this has to be 10, because that's the short side. It's opposite the 30. And the side opposite the 60 would be the short side times radical 3. That means this would be 10 radical 3. Okay. So hopefully that clarifies that. The key when you're doing this is really paying attention where the angles are. So the side opposite the 60 is the long side, which is the one we're looking for, ST. And the hypotenuse is the side opposite the 90, which is 2 times the length of the short side, which in this case would be 10. All right, so it says it wants it in nearest tenth of a centimeter. So they do not want it as 10 radical 3. So we need to simplify that. So let's use our calculator here. That's why it's a calculator section, right? So 10 times radical 3. Oh, we got to change the mode to classic if you're using one of these. 10 times radical 3. So 17, nearest tenth, so 17.3. We're going to keep that at 17.3. 17 3/10, and that's the measurement's going to be centimeters. Okay. To show you work, you'd want to maybe redraw this triangle to show you using the 30, 60, 90 formula. What is the length? Zoom in a little bit here. What is the length nearest tenth of a centimeter of TQ? This one right here. So these are perpendicular, so this is going to be a right angle. So again, we're going to use the 30, 60, 90. So we're going to write in 60 here. So we're looking for this. So this is the short side. We know the long side is 10, because we have that, right? So the long side is 10. So we're going to say, I'm going to redraw the triangle right here. So 30, 60, 90. So 2y, y, and then y radical 3. Okay. So y radical 3 is going to be 10. Excuse me. So I'll write this on this piece of paper. Excuse me. So y radical 3 is 10. We're going to solve for the short side, so we're going to solve for y here. So we're going to use a different color. We're going to divide both sides by radical 3. And we're going to get y equals 10 over radical 3. Oops. And we're going to multiply the top and bottom by radical 3. So we're going to have y equals 10 over 3 times radical 3. Okay. So it wants us to round to the nearest tenth of a centimeter, so let's go ahead and simplify that. So 10 divided by 3, 3 1/3, and we're going to multiply that by radical 3. So we're going to get 5.77, we're going to round that to 8, 5.8 centimeters. It's interesting that they had us round these. Usually they'd want more exact. You can tell this is an older MCAS problem. What is the perimeter to the nearest tenth of a centimeter of kite PQRS? Well, the perimeter is length around, so in this 20. So, okay, we know the short side is 5.8 of this. So this is going to be double that. So 5.8 times 2 is going to be, is it 11.6? Let's see, 5.8 times 2. Yep, so this is 11.6. This has to be the same. So we just add these all up. So it's going to be part D. So 20 plus 20 plus 11.6, or 6/10 rather, plus 11 6/10. What's that going to equal? Let's see. 20 plus 20 plus 11.6 plus 11.6. And you get 63.2. And again, this is an estimation, right? Because we're rounding those radicals up. So that's it. Cool. All right. It's kind of a weird problem, to be honest. That was 36. 37. If Q is not equal to 0, which of the following additive inverses, which of the following is the additive inverse of the expression below? All right, so additive inverse is when you can combine it with something and get 0 as your solution. So what could we combine with this and get 0? Well, it's going to be the same thing, just with an opposite sign. So it's going to be positive 2 over Q, which is right here. Because plus 2 over Q would equal 0. Okay. All right. Number 38. Almost done. Howard runs every day for 1 hour. Okay. The first half hour, he runs at a rate of 10 minutes per mile. For the second half hour, he runs at a rate of 7.5 minutes per mile. Okay. Excuse me. So which of the following is the total distance in miles that Howard runs every day? All right, so let's figure this out. We have the first half hour, which is 30 minutes, right? So for 30 minutes, he runs 10 minutes per mile. So let's divide 30 minutes by the rate he's going at here. So 30 divided by 10 is going to give us 3. So it's 3 miles in the first half hour. Okay, so 3 is the first part. Second half hour, so another half an hour, so 30 minutes. 7.5 minutes per mile. So we're going to divide 30 by 7.5. And that's going to give us, let's see, 30 divided by 7.5, 4. So he runs 4 miles. So we just add those together. We get 7. Okay? Pretty straightforward. This is the part that trips people up probably. Okay. Parallel lines Q and M are intersected by lines P and Q. Okay. The diagram below shows the lines and the measures of some of the angles formed by the intersections. All right. Do they tell us they're parallel? They do not tell us they're parallel. Oh, they do tell us they're parallel right there. Parallel, first thing they say. K and M are parallel. So let's go ahead and draw that so we know those are parallel. These lines are obviously not parallel, P and Q. Okay, lines K, P, and Q intersect at point R. Based on the diagram is a value of X. Okay, so let's see. So this is going to be, I'm going to start filling these in. So 80, you don't need to fill these all in, but I'm going to start filling. It makes it easier for me. Yeah, let's do this. So this is 80. This is 40, right? There's a few different ways to do this. I'll show you one way to do it. We know these three angles have to add up to 180 degrees because this is a straight angle. It's a line. So 40 plus this question mark plus 80 equals 180. So if I do 40 plus 80, I get 120. and I subtract that from 180, it's going to give me, oh, what am I doing? It's going to give me 60, so that means this is 60 degrees, right? That angle corresponds to this angle. And because these lines are parallel, that means they're congruent. Okay? And you'll notice that these angles are vertical, so that means these are also congruent. So this is to be 60 degrees. That's one way of doing it. You could also do it by saying, okay, well, this angle over here corresponds to this angle. That means this is 40. And then you could find x by just taking 80 and 40, adding them together, subtracting from 180, and using triangle sum. So there's multiple ways of doing it, but yeah, it's 60 degrees. Cool. All right. 38. Let's see here. Moving right along. There's 3 problems left here. Okay, the scatter plot below shows the weekly income. Oh, let's zoom in a little bit here. Shows the weekly incomes in U.S. dollars for 15 individuals and the number of years of higher education each individual completed. Okay, so the more education is on the right, and then their income goes up. Okay, so all right, which of the following graphs best represents the best line of best fit for the data shown in the scatter plot? All right, so let's see which one of these is the best one. So, which of these best represents the data? Well, this is out. That one's not bad. That one's not bad. This one's great. Because see how it's really centered on the data here? So I could see this one's immediately knocked out. These two I could see why people would think it's right, because they're not terrible, but this one's just better. It just better represents the data. You can see how the points are more close. They're basically closer. It best represents the points. Okay. Okay, 2 more. All right, hold on a second here. Okay. So the histogram below shows the height in inches of students in Landon's class. How many of the students in Landon's class are at least 65 inches tall? At least 65. So from here to the right, right? So this is 3. This is 5. Let's zoom in over here. This is 1, and this is 2. So let's add these all up. So 3 plus 5 is 8, plus 1 is 9, plus 2 is 11. It should be 11 students. All right. Okay. What fraction of the students in Landon's class are between 65 and 68 inches tall? Show or explain. Okay, so between 65 and 68 is this column right here, these 2 columns. So there's 8 total here. So there's 8. This is what fraction of all the students. So the bottom number is going to be the total students in the class. So let's count them all up. So it's 3, 5, 1, 2. This is going to be 5. This is going to be 6. So let's add these all up. So 6 plus 5 is 11, plus 3 is 14, plus 5 is 19, plus 1 is 20, plus 2 is 22. So 8 out of 22, and you can simplify that, divide them both by 2, and you're going to get 4 of 11. And that would be the fraction. Okay. Part C, what could be the median height of students in Landon's class? Show or explain. All right, so there's 2 ways to do this. I'm going to list the numbers out. Actually, no, hold on. This is actually a tough one because it's categories. Okay, so there's 22 students. So the median's going to be the middle number, which means it's going to be in between the 11th and 12th student. So if you look here, the 11th student is here. It's in this column. The 12th student's here. So it's going to be in between these 2 columns. Now, I could write this out. I'm going to show you how I'd write this out. I'm not going to recommend doing it this way, but you could. All right. Some scrap paper. Let's see. Okay, so we got. It's tough to do listing these up because they're categories, but let's try it anyway. So 61 to 62, 61 to 62, and you could do this 6 times, which I'm going to do, just to make a point. 61 to 62, 1, 2, 3, 4, 5, 6. So there's 6 of those. And there's 5 of these. 63 to 64. 63 to 64. 63 to 64. You can see why this is annoying to do in these multiple terms. It's not just one number. It should be 5 of these. 1, 2, 3, 4, 5. I'm going to have to go down below here. Hold on. Do one more. So there's going to be 3 of these. 65 to 66. 65 to 66. 65 to 66. That's 3 of them. And then 5 of these. 67 to 68. Oh, I totally screwed that up. 7 to 68. 68. 3, 4, 5. Okay. And then 1 of these, 69 to 70. And 2 of these. 72, 71, 72. That should be 22. Let's just count, make sure we have them all. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. Yep. So now we just do high-lows to figure it out. So let me zoom out so you can see this all. Again, this is kind of not the best way to do it, but it works. The most efficient way is just do it right on the histogram. Low, high, low, high, low, high, low, high. It's in between these two values. So it's between 64 and 65. Okay, so it says what could be the median height? So it'd be 64.5, because it's halfway between 64 and 65. I'd say 64.5 inches. Half inches. Okay. Landon's teacher will add her height to the data. She's 65 inches tall. What will the new median height be? Less than, equal to, or greater than the median height? Okay, so she's going to be in the new one. So she'll be here, which is going to increase it. So because she's going to be in this column, we're going to add another one right here. So put another one, 65 to 66, which would shift the median one space to the right. So the median would actually end up increasing. So new median would actually end up increasing. That's where you can see shift to right. So you can see where there's a value in taking the time to write this all out. So it makes that next part actually easier, which we didn't even know that was going to happen, but it was definitely makes it easier, I think. Okay. So let me the answer key. The last one, which I think is right here. Yep, here it is. Okay. Last problem. Here we go. A small cube and a large cube with edge lengths represented by expressions are shown in the diagram below. All right, so we have x inches and 3x inches. The small cube has a volume of 64 cubic inches. What is the value of x? Okay, so this is a volume of 64. So we know the volume of a cube is going to be s to the third power. We know this because it is on this formula sheet. Volume of a cube, length of an edge is x to the third power. So we'd simply say x to the third power equals 64, and find the cube root of each side. Okay, so what number times itself? X times x times x equals 64, and this can be 4. You can plug that in your calculator to calculate your section. So if you go with this button here, so excuse me, so 3 and 64, yep, 4. There you go. All right, so yeah. So by the way, hopefully people know this. This is this variable in front of the radical symbol. This can basically allow you to make a cube root or a fourth root or whatever root if you know how to use this properly. Just put a 3 there, and that makes this turns this into a cube root. Very, very useful. Okay, part B. What is the surface area in square inches of the small cube? Show explain how you got your answer. So surface area. Let's find the surface area formula. Right here. So 6s squared. All right, easy enough. We'll do bar B down here. So 6s squared. So s is going to be the length of the side. We'll call it x before, but that's going to be. So I should write this down, shouldn't I? X equals 4. I don't know why I didn't do that. Inches. So we're going to plug this in for S. So 6 times 4 squared, 6 times 16, and was it 96? Yeah, 96. 96 inches squared, square inches. So 96 inches squared. Okay. Part C. The surface area of the large cube is how many times the surface area of the small cube? Show or explain how you got your answer. So let's figure this out. Let's figure out what the actual surface area is. We know it's 3x, right? So it's going to be 3 times 4, which is 12. So let's do that. So part C. So 6 times 3x, let's just establish what that is. So 3x is 12 because, so 3 times 4 is 12. So that's what that is, 12 inches. So 3 times 12 squared. 12 squared is 144. And 144 times 6 is 864, I believe. Double check that. 6 times 144. Yep, 864. Okay, so we want to know how many times larger the surface area is from the other one, right? Yep. So we're just going to divide that by the previous one. So divide this by 96, I believe. What does that get us? Divide by 96. It's 9. So it's 9 times the size. So 9 times. Okay. Last part. The volume of the large cube is how many times the volume of the small cube. So let's find the small volume first. So small volume is going to be, we already found it, didn't we? It's told, actually, we're told it is at 64. So small is 64. And we're going to find this. So it's going to be 12 times 12 times 12. So 12 cubed, let's see what that is. So 12 to the third power is 1,728. So 1,728 is a large. Let's divide that by the small. And it'll give us how many times bigger it is. Divided by 64. 27. So it's 27 times. Whoa. Whew. 27 times bigger. And that's it. All right, so hopefully that explains most of it. I hope this helped. If you're preparing for the MCAS, either as I'm making this video, we have it in like a week. If not, if this is in the future and you're watching this, hopefully this is helpful. And if it wasn't, that's fine. Let me know so we can make these more helpful. The whole point of these videos is to help students get ready for the MCAS and pass. All right, thanks for watching, guys.